So here we are for example 12.2. This is the one I didn't quite finish in class. So let's again look over the given. So a small projectile, so that's important. It means we can use particle kinematics. But really, you know, we had to do that because this is chapter 12 and you haven't learned rigid body kinematics yet. But anyway, a small particle is fired vertically downward into a fluid medium with an initial velocity of 60 meters per second. So that tells us that V0 is 60. Due to the drag resistance of the fluid, the projectile experiences a deceleration of this. A is a function of V in meters per second squared, where V is in meters per second. Determine the projectile's velocity and position 4 seconds after it's fired. So again, what are we given? So we know it's a small projectile. I won't write that down. But the initial velocity is 60 meters per second. And we'll take positive going down. And we're also given the equation for the acceleration is minus 0.4 v cubed in meters per second squared. Okay, that's all we're given. They then want us to find out, so what's required? Find the projectile's velocity and position 4 seconds after it's fired. Okay, so the solution. So if you look at this, we have acceleration in terms of v. They want distance s. There's no mention of time except when time equals 4 seconds. And so I think what we should use is the relationship. Remember we did this, a ds equals v dv. Okay, so well, we do need to know time is 4 seconds, so maybe we should also use A equals dv dt. Okay, so let's try that. So first of all, let's try the first one and see what happens. So we get minus 0.4 v cubed ds equals v dv. Oh, that's ds, not d3. Okay. Okay, so separate the variables. I can see this is not going to work, but let's continue this and see what happens. V divided by minus 0.4 v squared is minus 1 over 0.4 v squared. So v divided by minus 0.4 v cubed is minus 1 over 0.4 v squared dv. That's good. And ds. And so we could integrate that, but the problem we're going to immediately have when you integrate ds, we know it goes from 0, but we don't know where it ends. We know it ends at 4 seconds, but we don't know how far that is. So I said in class this is how to do it, but now that I'm working out, no good. So let's try the other equation. Okay, so let me switch this back to black. So let's try the other one. A equals dv dt. Okay, so the acceleration is given as minus 0.4 v cubed equals dv dt. This will work. So we separate the variables. We get dt on one side equals dv all divided by minus 0.4 v cubed. Okay, so let's just do that as 1 over minus 1 over 0.4 v to the minus 3. Okay, that's the same thing, dv. So we just integrate both sides. Now this time we know we're integrating from 0 to 4 seconds dt will equal integral from v0 to v, and I hope we were given v0. There it is. V0 is 60 meters per second, and we're taking down as positive. Okay. And then it's minus 1 over 0.4 v to the minus 3 dv. So the integral of dt is just t from 0 to 4. Okay, and integral of minus 1 over 0.4 v to the minus 3 is minus 1 over 0.4 v, you add 1 to the exponent v minus square and you divide by that. Okay, I believe that's right. And that goes from v0, which is 60, to v at 4 seconds. Okay, so we plug that in. 4 equals 1 over 0.8 v to the minus 2 from 60 to v. That equals 1 over 0.8 60, oops, sorry, v, oops, sorry, v to the minus 2 minus 60 to the minus 2. Okay, so I need to get my calculator out and I'll be right back. Okay, so this is easier for me to understand. I can't quite visualize it, so I'm going to write it out longhand. 1 over 0.8 times 1 over v squared minus 1 over 60 squared. So we're going to have to solve for v. And throw the 0.8 on the other side, so 0.8 times 4 is 3.2. 1 over v squared minus 1 over 60 squared. So we're going to have 3.2 plus 1 over 60 squared. That's going to basically just be 3.2 equals 1 over v squared. So v squared equals 1 over all that other stuff on the other side. And finally, v is going to be the square root of all that stuff. Okay, so I've got my calculator. Oop, 1 over 60 squared. So I hope I got this right. 60 squared, 1 over that, plus the 3.2. It's basically still 3.2, 1 over that. I'm going to double check I didn't make a mistake here after I do this. And then the square root of all that. 0.559. These are meters per second, I believe. Yes. Okay, so the velocity at 4 seconds is 0.56 meters per second. Now box that. And there we go. So I realized I didn't read this carefully enough. So if you look back up here, it says find V and S. So I didn't find the displacement S, so let's do that now. So we need to find the displacement S at 4 seconds. So you have an equation with displacement and time. The only thing we have for that is, remember, the velocity is a change in displacement ds dt. We've already gotten the velocity before up here. I've highlighted it. We integrated this thing here to get the velocity. We integrated the acceleration, and this is what we got. But instead of going from 0 to 4 seconds, we're going to integrate from 0 to t. So where that 4 is right here, we're going to replace it with t. And so what we will get, let me go down here. Let's write this in. T equals minus 1 over 0.4 times 1 over minus 2, 1 over v squared minus 1 over 60 squared. We need to solve that for v. Okay, so we're going to have, let's see, t equals 1 over 0.8. The negatives cancel there. 1 over v squared minus 1 over 60 squared. Okay, so I'm going to just quickly do the algebra here. And finally, 1 over v squared, 0.8t plus 1 over 60 squared. Or you flip that and take the square root, you get v equals 1 over all that stuff, square root, and that equals 1 over the square root of all that stuff, and that's the same as all that stuff to the minus 1/2 power. So all that stuff being 0.8t plus 1 over 60 squared to the minus 1/2 power. Okay, so there we have v. And remember, we're using this relationship here. So let's just write that all out again. So 0.8t plus 1 over 60 squared, all that stuff to the minus 1/2 power equals ds dt. We can now separate the variables, put all the t's on one side, all the s's on the other side. So we have 0.8t plus 1 over 60 squared minus 1/2 dt equals ds. Integrate that from 0 to 4 seconds. Integral from s0 to s ds equals s minus s0. And let's see what s0 was. It was shot from the surface, which is 0. S. So finally, S at 4 seconds is the integral from 0 to 4 of 0.8t plus 1 over 60 squared, all to the minus 1/2 power dt. So I don't know that one offhand. I'm thinking I don't have Wolfram Alpha handy, so we're going to have to use substitution. So let u equals 0.8t plus 1 over 60 squared. Du then is 0.8 dt, which means dt equals 1 over 0.8 du. Okay, so plug everything in there. So we have dt is this, and that all this stuff is u. So let's put that in there. S of 4 equals the integral, I'll leave the limits out for now, of u to the minus 1/2 power, and dt is 1 over 0.8 du. So I can do that integral, add 1 and divide by the exponent. But what we need to figure out is when t equals 0, what does u equal? So u is 0.8t plus 1 over 60 squared. So when t equals 0, u is 1 over 60 squared. And when t equals 4, u equals, what, 0.8 times 4? So it's 3.2 plus 1 over 60 squared, right? So 3.2 plus 1 over 60 squared. Okay, so let's do that integral. Integral of u to the minus 1/2 is you add 1 to the exponent, right? So u to the 1/2, and then divide by 1/2, so it's 2. Okay? 1 over 0.8, all evaluated from 1 over 60 squared to 3.2 plus 1 over 60 squared. So s at 4 seconds equals, let's see, 2 over 0.8 times the square root of 3.2 plus 1 over 60 squared minus the square root of 1 over 60 squared. And let me punch that out real quick. Having trouble here. Square root 60 squared. 1 over that. Add 3.2 of that. Take the square root. And it's 4.43 meters. Let me double check that real quick. So it's roughly going to be the square root of 3.2 times 2 divided by 0.8. Yeah, that's right. Okay. Let me double check that with the solution, and I'll get right back to you. So yes, that was right. So this problem is over. Thanks.